about profits. Well, you've got tape decks and radios. Sir?
Weren't you working over 2? This is number 4.
What's that?
I think you said you were working begin with number 2. This is number 4.
No, let's put 5 stars. Good. 3 is the exact same thing as
that's what I
number
was saying.
Yeah, 3 is the exact same thing as number 1. That's why I figured I'd go into 4 here. So when I'm looking at this one, I know I want to maximize my profits. So I go through the stuff. Each radio, I make a profit of $19. Each tape deck, I make a profit of $12. So I'll use R and T. Now, as I go back into the problem, it tells me they have a capacity to manufacture at most 600 radios and at most 500 tape players, which means can they make more than that?
No.
No. So the radios are going to be capped at 600. There's going to be less than or equal to 600 of them made. Tape decks, same deal. Tape decks, less than or equal to 500 of them. Also, going with that, can you have negative radios?
No.
Can you have negative tape players? So I know that both of them are going to be first quadrant problems. Okay. The last bit of information they give us in this problem talks about the cost it takes, or cost that is in line with the manufacturer. They say they can spend up to $8,400. Can they spend $8,400?
Yeah.
Can they spend more than that?
No.
No. How much does it cost to make a radio?
$10.
$10 per radio, plus, what was it, $12 for a tape deck.
But why would you make a tape deck for $12 and then sell it for $12?
It's not saying they sell it for $12 and make a profit of $12. So they sell it for $24. Okay? And that's how you wind up with this. Those are all of the constraints that you need to worry about. You have a first quadrant problem. Let me do this. We have a first quadrant problem, and some pretty quick intercepts to get. So as we go through this, we plot it out. I'm going to say R and T. And the reason why I'm doing that as R and T is because, well, alphabet, but it gave me radio first. That way I know that it's in my ordered pairs. It goes R, T. So we know it's first quadrant problem. So R is greater than or equal to 0, so it's everything going to the right until it's stopped at 600. And it's moving inward. Pretty okay with that?
Wait. No, move
It's, you can go up to 600, but not past it. So you can make anything less than or equal to 600 radios. Your manufacturing plant only has the ability to make that many of them in a day or however long period. You do the same thing with the 500 and the 0 on the T. So here's 0, 500 for this ordered pair. And it's moving downward and upward. So right now we have 4 points, 3 of which we know via the intercepts of zeros. That fourth one is out in space there, and we also know what their ordered pair is because it's a vertical and a horizontal line, one at 600, the other one at 500. So this ordered pair is 600, 500. What's up? It's at 0. I haven't gotten to that last one yet. I have my other point of inflection right now at 0. That last line, that 10R12T, is the last one to place in. So when I place in that 10R12T, we do the cover and solve method again. To get the T intercept, I take 8,400 and divide it by 12. I believe that is 700. So I know it's at 700. And I do the same thing here, and it's at 840. Let's place out here. I need to decide which way to shade that. Do I shade it moving in towards 0 or away from 0? In. I shade inward towards 0 because at the origin is true. Which gives me 2 more points to check. I need to figure out what those 2 points are. 1. We have 5 happy points to look at. We know 3 of them. And it's really nice that we have vertical line, so we know the x value for one of them. And we have a horizontal line for the other one, so we know the y value, or r and t, excuse me. So if I use the r value here of 600, I substitute in 10 times 600, well, 6,000 plus 12t is 8,400. 8,400 subtract 6,000 is 2,400. 2,400 divided by 12 is 200. So it gives me a point here at 600, 200. I do the exact same thing at the other point on the horizontal. On the horizontal, I have a value here of 500 for the t. So I take 10r, 500 times 12 is 6,000 again. Ten goes into 2,400 how many times? 240. And there's your other ordered pair. So this allows us then to find those 5 points of inflection. Remember, point of inflection is just where the graph is changing direction. That's all. It's just a fancy way of saying it. The boundaries of our shaded region, if you will. All we have to do is test those 5 points with our objective function, which are a profit, which was 19r plus 12t. So I tested at 0, 0, 600, 0, 600, 200, 240, 500, and then 0, 500. And whichever one of those gives me the largest number, there's my maximum minimum of how many of each I should manufacture. Yeah. Sure, which one is it?
It's,
The 600, 200? So 600, 200 gives us our maximum value. So at my electronics plant, Reynaldo Electronica, es muy importante para cinta players. That means tape player. What's that? Mis accente es muy bueno. Hola, ¿cómo está usted? I've been told I sound like Buzz Lightyear, Spanish Buzz Lightyear. Hola. Necesito un papel y uno de lápiz, por favor. Oh, it's only been like 10 years since I've been in high school. Yes, it's been 10 years since I've been in high school. This is my 12th year of teaching. You do the math. Yes, ma'am. Yeah. Yeah, because whichever one of these gives you the maximum, that means that that ordered pair, 600 radios and 200 tape decks, if I sold that many, that's what's going to give me my maximum profit. All right? So for those of you guys that weren't around, what we've been working on as far as the quick graphs and the shading and figuring out the boundary regions, all we're doing now is taking it into another step by coming up with some, I don't want to say constraint, but some profit or something you're trying to solve for. And that's what we're looking at here. Okay. What was the other one I wanted to do with you guys real quick? Nah, that one's awful. Oops.
What would the answer be?
I'll make sure you wear it on your birthday too. We have you're sooner.
Jaden, you look good.
All right. Let's add this one. I've got 3 more to give you guys this evening. We'll just add them to what you've got going here, and we'll collect all of it tomorrow. But I want to walk through another one with you guys now. I apologize I did not print this one, but we can kind of, it's not that terrible. I believe it said minimize costs. So, let's take a couple of minutes and walk through this and see what we can come up with on how to set it up. In this example here, we are an appliance store manager now. And we are ordering chest and upright freezers. A chest freezer costs $250 and it delivers a profit of $40. That's slim profit margins there. That's actually not that bad. You're selling for $290, 40. What's 45 and 250? So it's what? It's 625, 25. It's about a 24% profit. Actually, it isn't bad. Anyway, so it gives you a $40 profit. And an upright freezer costs $400 and has a $60 profit. The chest freezers are cheap. It depends on what size it is, because freezers nowadays aren't really cheap. I know I need a new one. Based on previous sales, the manager expects to sell at least 100 freezers. It doesn't say what type, but a combination that will add up to sell around at least 100 freezers. Total profit must be at least $4,800. Basically what that is allowing them to do is that if their total profit must be at least $4,800, that's going to cover their what's called overhead. You ever heard of that before? Yeah. Overhead is what it costs to pay the rent, pay your utilities, pay your employees, and all that kind of fun stuff. Advertising and all that. So anything after you made that $4,800 is your profit. So that's what you're actually going to be taking home. Think back to your lemonade stand. We're going to talk about that one, not your crack stand. When we think about the lemonade stand, if your parents bought you, the Kool-Aid and the cups and all that stuff, they might be into their investment into you for about, we'll say, $5. So after you have made your $5, you've paid your parents back, and everything after that is your profit. So even if you only sell $6 worth of lemonade, you owed your parents $5, which means you only really made $1. It's still $1. You're right. This is the internal optimist. So that's the idea. That's how the business stuff works. You have to pay back what you owe before you can take your own money out of it. Okay. So, what is your goal? Careful. What is your goal?
Make profit.
What is your goal?
Keep profit.
Buy the least amount of, least amount of freezers you can order to get to 4,800 and 100.
You guys,
Like, that was really
you-
bad.
Minimize the cost.
Basically, minimize costs.
minimize costs. Your goal is to minimize costs. It's not a profit style this time. You want to minimize your cost. You want to figure out what is going to be the cheapest way for me to order freezers to minimize my cost. I don't want to order 100 of these $400 freezers because then I'm into it for 40 grand. Okay, I don't want to do that. But if I order 100 of $250 freezers, I might only be in for 25 grand. But is there some sort of a combination of the two that'll allow me to make more money off of that? So we want to minimize our costs. So we have chest freezers. So we'll call this an M for minimize our costs. We have chest freezers that cost $250. And our other ones cost $400. We'll call it a U. All right. Now, can we have negative values of freezers?
No.
No. So we know it's going to be a what quadrant problem? First quadrant. Now, it also talked about profit in this case.
Is that a Y?
That's a U for upright. Because that's how we walk. Some of us do. We try. All right. So we have our profits. We know, well, first of all, we know our C value has to be greater than or equal to 0. Our upright freezers has to be greater than or equal to 0. And we also know that how many total sales of the two combined should there be?
100.
100. We also know that the C plus U has to be at least 100. So is it going to be less than or equal to 100 or greater than or equal?
Greater than.
Okay. And what's the last bit then? We haven't talked about profit. Profit. The profit must be at least $4,800. So we have, how much profit do you make on a chest freezer?
40.
$40 on a chest freezer. Plus, was it 60 on the upright?
Yep.
And it has to be at least $4,800. And this allows us to create our shaded region. Okay. What's that? It is. Some of the ones we have tonight can be a little bit goofier. I have the more difficult ones tonight for you. Actually, 2 of them are tough. One of them's pretty easy. Actually, all right, I'm sorry. 1.5 of them are pretty easy. The other 1.5 are kind of tough. So if we start to break this one apart, we know that we have a first quadrant problem because you can't have negative freezers. And then it's just a matter of starting to plot things through. To be honest with you, I'm going to go, since I labeled this as C and U, I'm going to have my ordered pairs as C, U. Ah, boo, that sounds like something Murphy should say. What are your C? What are your C and U intercepts? We have intercepts at 100. And what direction does this shade outward? Or shade? I didn't say the answer.
I'm gonna guess out.
I'm going to guess you're right. Because it's shaded outward because what's 0 plus 0? Is 0 bigger than 100?
No.
No. So it's Es el falso está aquí. Es el true está allí.
Cierto.
Cierto, gracias. ¿Cómo se dice true? No sé. All right. So this one's moving out. Okay. Do the same thing with the next one. Ladies and gentlemen, come on. Cover and solve. 4,800 divided by 40 is another thing of saying 480 divided by 4. 100. 4 goes into 4 how many times?
120.
Did you guys ever see shortcut math?
No.
Maybe. They just gave us calculators. It's like, oh.
120. Oh my gosh.
Oh, you get rid of the zero. Yeah.
4 goes into 4 how many times?
Well.
Any left over? 4 goes into 8 how many times? Any left over? 4 goes into 0 how many times?
What? Why did they just?
Why did they teach us so easy?
Hey guys, this is just shortcut math. This works for anything. I actually do this a lot when we get into like some polynomial stuff. We do a lot of quick divisions and things. You're gonna need to rely on knowing how to divide and work through things quickly. If you've never seen that before, come in and I'll show you how to do this. It's really, really, really easy. Okay. I mean, it's the same thing if you're doing long division. It's 4,763 divided by 3. Instead of writing this out long form, 3 goes into 4 how many times? 1. How many are left over? 1. 3 goes into 17 how many times? 5. How many are left over? 2. 3 goes into 26 how many times? 8. How many are left over? 1. 3 goes into 13 how many times?
7.
4. So it's 1584 and a third.
Oh.
That's all it is.
Or you just gave us a calculator.
Yeah, but number sense is easier. So anyway, back to this one. So we had the intercept then at 120 for the C value. And the other one, 6 goes into 480 how many times? 80. 80. I dropped the 0. I did this. I did 4. I did that, so I did 480 divided by 6. I get 80. Intersects there. It doesn't go through origin, so what's 0 plus 0?
0.
Is 0 bigger than 4,800? You're like, no, it's not. It is false again here, which means it's shading outward. So when we start shading outward here, we wind up with a viable region. Comes down here, turns, turns, and goes. So we have this region here to worry about, which means I need to find one intersection point. I need to find the intersection between these two equations. And we can do that via system of equations. And remember when we did system of equations, we had a couple of different methods. Elimination, substitution, or linear combination. Yeah, or I can do this. C is 100 minus U. What you're saying by going to linear combination, there's nothing wrong with that. Guys, I'm really sick and tired of talking over people. Okay? I get it. You understand it's fine. Other people might not. Please. We have that. You can go linear combinations, then go to your elimination method. Or if you want to use direct substitution, it works out the same. I see whenever I have variables that are just coefficients of 1, I'm going to jump right to a substitution. I think sometimes it's quicker. It's just my own opinion. So I wind up with 40 times 100 minus U plus the 60 U as 4,800. Those of you guys that have been gone for a day or so, remember, whenever you're checking for the intersection, don't worry about the inequality. You're trying to solve a system of equations. You're trying to find the exact value. You're not going to have an inequality symbol for that system, for solving the system there. Okay. So let's see. It's 4 grand minus 40 plus 60. Oops, forgot the U. Apparently, I've started to write things on angles. Oh well. Let's see. 20U is 800. What is that? 40.
Yeah.
So if U is 40, C is 60. So that leaves me with my last little bit to go back to my my objective function. Our objective was to minimize costs. We have only 3 ordered pairs to worry about. We have it at 0 and 100, 60, 40, and 120 and 0. And we're going to check that with the 250C plus 400U. And that's how you figure out which which combination of those two is going to give you the least bang for your buck, if you want to think of it that way. I think, if I'm not mistaken, I think it's the 120 and 0. Am I wrong? I don't know. I'm just guessing. I should guess. So there's your 40 grand. Okay. Which to me, yeah, that might be the best way to minimize your cost value, but if you only have, what would be, yes ma'am?
Oh, I was just gonna answer.
What were you gonna ask?
I was gonna answer, because like I know what you're gonna ask.
What was I gonna say?
You're gonna say what would be like the best way to like satisfy all your customers, because if you have all the chest freezers, then someone's gonna come in wanting like, upright freezer, and then you're not gonna have it, so if anything, you'll be wasting money by buying too many chest freezers, which you won't sell.
And that's the idea here. Yes, this is the correct algebraic response. But in the real world, do you want to leave yourself short? No, you don't. In my mind, if I was running the business, I would do that. Because you're so well within your minimized cost value anyway. Why would you turn away customers that want to spend money? Because as you start to get in there, because your brother's doing business calc, right? He's taking other business classes as well. He probably sits there and hopefully does his homework and reads. A lot of times in business, you look at, like they said in this problem, what's called historical data. When you go back and look at historical data, you know certain times of year, certain things are purchased and certain things spike in values, or they spike through and go through that. Years ago, I was a manager with Home Depot, and I was in charge of ordering merchandise, where you had sales trends. You know what certain things were more prevalent during certain times of the year versus others. So you knew certain times of ordering more product to have it on hand to sell it, where you still have that overhead value of that stuff sitting there on the shelves. And if you have too much of it, you're losing money because other things could be on the shelves to sell. Does that make sense? It's kind of like in the summertime, you don't see Christmas unless you go to Hobby Lobby starting, August 15th, we saw the Christmas stuff up. It was July 4th, there was Halloween stuff up. Seriously? But It's things like that. You start looking at this seasonality of items. There's certain times of year. Right now, I was at Target yesterday with our son, and there's winter coats out. It's 100 degrees out. I know. But the thing is that you're going to start to see, and that's the seasonality of shopping, and that's the idea. Yes, the correct answer to this problem is have 120 chest freezers. In the real world, you're an idiot if you have only 120 chest freezers. But I want this big giant one. Yeah, I can't sell you one because I don't have it. Well, then I'm going to go to Lowe's or I'm going to go to somewhere else and I'll buy it there because that's what happens. So ask your parents. They'll tell you. They probably had to leave a store because they didn't run out of stock and went and buy it someplace else. Yeah. I mean, it's stupid stuff. You're like, how do you run out of this? That's, to be honest with you, more and more brick and mortar style stores are going to start to go away because you can get everything you want in 2 days. Click. And if you don't like it, what can you do? Return it for free. If it doesn't fit, you ship it back. It's so true. It's so true. Do you guys know why there's so many mattress stores now? Have you noticed that? What? Hold on. What's that?
You can't like order mattresses online, like.
Oh, you can. No, you can. You can absolutely buy it. But do you know why they're everywhere?
Because you can't return them.
Well, not just you can return it. I mean, some of them have that return policy on it, of like you have X amount of days and all that. But here's the thing: the markup. You guys understand what I mean by markup and margin?
Yes.
The markup here they were saying is $40 markup, which worked out to be like a 24% profit. The markup margins on mattresses are like 100, 200% markup. They cost nothing to make, and they charge thousands of dollars for them. A $1,000 mattress probably costs $200 to make. So you have all these mattress stores all over the place. Do these mattress stores even carry the mattresses in stock? No. So they don't have to have any overhead by holding merchandise in the back. They have a warehouse that's centrally located that will just ship you whatever you want, and they have a rotational basis. That's why certain places you can only get deliveries on Tuesdays and Wednesdays. Other places you only get deliveries on other days. So mattress stores, they only have to sell a couple of mattresses a day, if not even just one, and they're making money because the margins are just ridiculous. That's why everybody is selling mattresses. You can buy a mattress at Menards. You can buy one at Kohl's. You see them all over the place. That's why there's 2 mattress firm places across the street from one another, another one down the road, another one across the valley. They're all over the place because it doesn't cost anything.
The thing is, mattress firm doesn't cost a lot.
But it doesn't cost much, but they're still making boatloads of money. Look at this, Econ 101 in math. Yay! So, what's your homework? I'm glad you asked. Get me back on task. Back on the same page that we were on 2 days ago with the constraint problems we first started graphing. Yeah, 166, 167. It's still in that pop-out page on the where it's still on that on the website where it's just that little pop-out screen of 3.4 the linear programming. It's on that exact same spot. I'd like you guys to do numbers 21, 22, and 23. To be honest with you, I would do number 22 first. Okay? I would do number 22 first, and then probably 23, and go back to 21. 21 is not that it's more difficult. What happens in number 21 is that you do need to make one conversion. How many quarts are in a gallon? 4. There's a big hint. Also, it deals with, I hate the letters that they choose here. They have orangeade and berry fruity. Orangeade is mixed with orange juice, berry fruit and raspberry. Berry fruity is made of mixing raspberry and orange. So they have O's, which looks like a 0 if you're using that.
Oh, that's smart.
It is. So what I usually do when I write out the equations for the orangeade and the berry one, I use 2 letters to represent orangeade or orange juice. I'll use OR.
You don't have to number 5 on that one. Number 5 is written really badly. There's some stuff that has to get changed to make it work. I didn't change it before I ran it off, so I'm not going to bother with it. Yes, ma'am. It's 167. It's the very next page from what you did the other day. Like I said, it's in the same pop-out screen. I'll show you on the website.
Is it in the old book?
Yes, it's the same place it was the other day. So if we're back here and we click on the old book, remember how it had that little pop-out? And I have the date here, the Wednesday, and I have the numbers for you to do, okay? I'll throw it on the calendar as well. Okay?
Wait, what page is that?
It's right here. It's this part when you open it up in the book. I left it like that. Whenever we do old book stuff, instead of having to go to the actual website, I think what I'll do is just pop the actual the PDF in the website so it's less clicks. Because 15 clicks is stupid. I did not, because I just added to it. I'm going to collect these tomorrow. All right?